Welcome to your lesson on creating histograms for discrete and continuous data. For the first part of this video, just watch and listen, think. No need to write anything. We'll do the notes a little bit later. I'll let you know when. Let's take a look. On this slide here, we compare a bar chart and a histogram. Please note the main differences. Let's take a look. First of all, bar charts are often used to represent qualitative data. Notice here we do have qualitative data. It's just a count of, I don't know, maybe it's a pet store and you're trying to see how many of these animals are in the pet store. So we're just counting how many cats, dogs, rats, and so on. That's qualitative data. Now let's look at this histogram. Notice this data here along the x-axis is different. Histograms are often used to represent quantitative data. And notice this data here is a quantity, it's a numerical value. Let's notice some other differences. This bar chart, there's gaps between these columns here. In a histogram, there are no gaps. That's important. Notice on this side here, the y-axis, we have frequency or a count, and here also. So on here, your job is to look at these and decide, based on what you just saw, which of these are bar charts, which are histograms, and which are neither. So try that now for 1, 2, 3, and 4. What do you think? All right, let's take a look. This one is a bar chart because we have qualitative data and frequency here. Number 4, although we have quantitative data here, it is not a histogram because the bars have gaps in between them. Is it a bar chart? Well, it could be argued that it is, but in general, we're going to say this is not even a bar chart because we do not have frequency measured here to percentage. All right, and number 3, we see no gaps in the columns, we see quantitative data, and we see frequency here. So this is a histogram. And this last one also can be a histogram. Again, no gaps in the columns, frequency over here. So looking at histogram, let's make sure we know some words that deal with that or some vocabulary. These are called our class boundaries. As you may remember, in a frequency table, we can have a range of values and a count of how many. So for example, here we have 3 things that lie between these values. That's one class, this is another class. So these are our boundaries, this being the lower boundary and the upper boundary. And on the y-axis, we always have frequency or a count of data on a histogram. Right, here's a histogram and a box plot put together in one. This is a common way of representing data using 2 different representations. Let's take a look if this makes sense. In this bar chart, we can see we have a lot of data here. So if we have a lot of data right here and then less and less here, then it would make sense that the median value, the middle value, might be somewhere in here because you have a lot of values, And look, the median is right there. It's right in the middle here. So the middle value falls somewhere in here. And then over here, it looks like we have this data spread out a lot. And we can see that here because this is 25% of the data, another 25% of the data. So from here, this way, that's 50% of all the data, and we can see there's a lot of data spread this way, so that would make sense that 50% of it is there. All right, anything else? Minimum value is 2, and we can see these bars don't begin until 2, so that makes sense. Maximum value of 15, and that lies in between these. So this bar here represents any data between 14 and 16, and it looks like we don't have anything greater than 15, so that makes sense. All right, some more things about histograms. Notice this histogram has a lot of the data in the middle. It has kind of this nice shape like this. This is called a bell curved shape. It looks like a bell, right? So that's kind of a standard distribution of data, and our box plot for that might look like this. The median is somewhere in the middle, and then the data spreads out evenly both ways, and you can see that here. That's symmetric. This kind of histogram is called right skewed. All right, so now the highest point is here, but then the data kind of drags to the right side. That's called right skewed. And you can see on the box plot that there's a lot of the data to the right like that. This part here is really big. There's a big spread in that 25% of the data, and that's what this shows. And if you drew just a curve for it, you can see that also. Like here's the right skew here. So going the other way, a negative curve or negative histogram has left skew to the left here, and you can see this data trails off to the left, and also in the box plot you can see that from the median down to the min, 50% of the data is spread out a lot, and then the upper 50% is more tight here, and you can see that here. All right, let's take some notes. So now let's use the paper that I gave you in class. We're going to add notes to that paper. First of all, we're going to look at continuous data. And a reminder, continuous data is quantitative data that can be measured. The situation we have here is there's a tennis player, and we've measured how long it takes the tennis player to complete a serve measured in seconds. So for example, one serve takes 2.1 seconds, another one takes 2.3, and so on. Let's complete this table. Again, remember in continuous table that it's shown like this. This is greater than or equal to. That means time here is from 2 onwards, and then here at the upper end it's not equal to, so it goes up to 2.2 but does not include 2.2. So 2.1 or 2.19 would be okay, but 2.2 would fall in here because 2.2 is included equal to in this set here. So make sure you remember how continuous works. Again, this number here is the same as this, and these symbols are like that, while these are like this. So frequency is 4 of this one. Let's take a look. Here's 2.1, which is part of that data set. There's 2, there's 2 again, and there's 2.1. I think I've checked all the values that fall between 2 and 2.2, including ones that are 2 but not including 2.2. So there's 4 of them. Lower boundary is 2.0. Upper boundary here is 2.2. All right, let's look at the next one. We're looking for values between 2.2 and 2.4. That's right here, 2.2 and 2.4. So I see 2.3, 1, 2.2, 2, 3, 4, and I see another one, 5. I think that's all the values that are between that. So I'm going to put 5 in here. And the lower boundary is 2.2, upper boundary is 2.4 here. All right, now try that for the last one here. What is the frequency going to be? How many values lie between 2.4 and 2.6? Hopefully you got 5 as well. Don't be fooled by those two. They're included in this data set, but this table doesn't allow for these to be counted. It would be in the next class here if we had another one. But this table ends here. Notice 2.6, it doesn't have the equal sign, so 2.6 is not included here. So don't count those. If you don't count those, then you should count 5 of them, lower boundary, upper boundary, 2.6. Now let's take the bars. Here's how the histogram works. So you basically mark the lower and upper boundaries here, right? 2, 2.2, 2.2, 2.4, and then you just draw a bar that goes as high as the frequency. So the first one was 4. Next one, between 2.2 and 2.4, we have 5, so it goes up to 5. And the next one again is 5. All right, let's look at the next example. We have the heights of plants. 59 plants were measured. Complete the table. Let's see if you can find, let's see these ones here. What will be, let's say, what would the last one be here? So fill all these in, and then let's see what you think the last one should be. So here's what you should have for those. Again, make sure you mark them just right for continuous data. If this ends at 10, this begins at 10. And then there's no equal here, no equal, no equal. So there's those. All right, and then what value should go here? Well, hopefully you got 20. And the way to get that is to look at that there's data for 59 plants. You could have added up all the numbers that we saw before. 1, 2, 3, 4. Add those 4 numbers. 5 plus 12, 17. Plus 15 is 32. Plus 6 is 38. Wait, is that right? 17 plus 15, wait, 32, 38. Huh, maybe this should be 21 here. That might be an error. So let's change that to 21. Okay, and then fill in the boundaries, sort of the 10, 10 to 20, 20 to 30, and so on. All right, to create the histogram, we should label the axes appropriately. This x-axis, I would say, well, you need to do it following the class boundaries, so to 10, 20, 30, 40, 50. The y-axis, you have different choices, but our highest value here is 20, or I just said this should be 21. So then if this needs to go to 20, 20, you can go 4, 8, 12, 16, 20. That makes sense. Maybe you did by 5s. Either way is okay. So I chose to go by 4s. First bar is 5, which is this frequency. Next bar is 12, this frequency here. Next bar is, well, it should be 21, like I said, 15 for the next one, and 6 for that one. So there's your histogram. Again, the bars are connected, and they go from lower to upper boundaries. Next, flip it over. We're looking at discrete data. Remember that discrete data is quantitative data that can be counted. And here we have a situation where we have a youth gathering. There are attendees aged 9 to 24, and the ages are given here. These ages are given as whole numbers, so we're just counting the age. We're not giving a precise value, just counting the age. All right, so here we have, notice this is different now, okay, than the continuous side. Let's take a look at the differences. Here's 9 to 12, but both of these are equal to, because we have ages from 9 to 12. We want to include 9-year-olds here. We want to include 12-year-olds here, and then also 10 and 11 in between. Then this number is not the same as this one, as it was in continuous. That's because we cannot have values between 12 and 13. We can only have whole numbers in discrete data. So we end at 12 here, begin at 13 here. So here we would have ages 13, 14, 15, and 16 included. So anyway, 9 to 12 is 5. Let's take a look. Oh, let's fill in the rest of these. There's our other categories there, our class values. And then I'm going to count the ones from 9 to 12. So 11, 9, 10, 9, and 12. Cross those out. Those are the only ages between 9 and 12. There's 5 of those. Oh, there's one more there. No, sorry, that's the next one. So now, how many would you get here? Count this number here. Let's see what you get. 1, 2, 3, 4, and 5. I just crossed out all the values between 13 and 16. 5, it's also 5, just like the first was. And our lower and upper boundary, let's take a look, because these are done a little bit differently, the continuous as well. Since here we have a gap between 12 and 13, the upper boundary we don't say is 12, we say is 12.5. It's the number that lies between 12 and 13. And the reason for that is when we draw our bars, we want our bars to be connected, right? If our upper boundary was 12 here, and our next boundary is 13, there would be a gap between 12 and 13. In order to make it connect, we go 12.5 right in the middle, and then the lower boundary also go like below that one, pretending that we went in the middle of that one, and whatever the lower one below that would be, so 8.5. So here, notice, our lower boundary is what lies between 12 and 13, 12.5, and our upper boundary is what would lie between 16 and the next number, which is 16.5. So now count up how many ages you have between 17 and 20, and then give me the lower and upper boundaries there as well. Hopefully you got 6, and then 16.5, 20.5 are our boundaries, and the last one should be 8, and then 20.5 and 24.5. If you draw those bars between 12.5 and 16.5, we have 5, sorry, between the ages of 13 and 16 is 5, and that's drawn between 12.5 here and 16.5, be very accurate there, and we have 5. Next one is between these values, 16.5 and 20.5, and that was a bar with 6, frequency of 6, so it goes up to 6 here, right here. Next one is 8. All right, let's take a look at the last problem. Here we have shoe size data collected from 122 people. Complete this table. So I'll ask you first question, what should this last class range be? What should this be for this last one here? Okay, so here's all the proper ranges. Hopefully you got this one here. Again, this is discrete, so it jumps from 19 to 20, 24 to 25, and so on. And now, what should this number be? Hopefully you got 22 for this one. Again, we did 122 minus all the numbers you had to get the leftover value, and now fill in the rest. Check your answer, check your bars,